Hello students, I am Dr. Jeevargi Pakirappa. Today in this session, we will do about the Laplace transform. Now, the Laplace transform we know about the transform, that one equation we can convert into another form, either to get easily the solution we are converting one form to another form, that is the Laplace transform. Now, what is this Laplace transform? Laplace transform widely used in almost all engineering fields like signals and systems, control systems and network, and in many other engineering subjects. Basically, this Laplace transform is used to solve the differential equation without finding the general solution for the given initial conditions, whereas we are doing in the linear differential equation, you are writing the complete solution as y equal to complementary function plus particular integral. If the initial condition is given, then after that we are finding the constants with the given initial condition. But whereas here, by using this Laplace transform, easily we can find, directly we can find the solution of differential equation. It is one of the very important tool to solve the linear differential equation. Now, in this Laplace transform, we are going to study about the basic standard formulas of Laplace transform, properties of Laplace transform. In the properties, we are studying about the linearity property, second one first shifting property, multiplication of t raised to n formula, fourth one division by t, fifth one periodic function, and sixth one second shifting property. Now, what is the definition of Laplace transform? Definition of Laplace transform: if f of t is a function of t, then the definite integration 0 to infinity e raised to minus st f of t dt, where s is a parameter, is called the Laplace transform. Now, if you consider f of t is a function of t, then the definite integration 0 to infinity e raised to minus st f of t dt, the definite integration 0 to infinity e raised to minus st f of t dt. Here s is a parameter which may be real or complex, is called the Laplace transform of f of t, and it is written as L of f of t, and it is written as L of f of t, that is Laplace transform of f of t is integration 0 to infinity e raised to minus st f of t dt. Now, this Laplace transform of f of t we can briefly written as f of s, briefly written as f of s, that is L of f of t is equal to f of s. Now, here L is the, it is just not multiplied with f of t, it is L is called the Laplace transform operator. L is called the Laplace transform operator. The definition of Laplace transform is L of f of t is equal to integration 0 to infinity e raised to minus st f of t dt. Next, what are the basic standard formulas, of Laplace transform? Totally there are 7 standard formulas. First one is L of 1 equal to 1 by s, L of e raised to a t 1 divided by s minus a, L of t raised to n factorial divided by s raised to n plus 1, then L of sin a t a divided by s square plus a square. Next one L of cos a t s divided by s square plus a square. Then L of sin h a t hyperbolic function a divided by s square minus a square, and L of cos h a t, it is s divided by s square minus a square. These are the 7 basic standard formulas of Laplace transform, and we can prove all these formulas just by using the definition of Laplace transform. If you take the first one, L of 1 equal to 1 by s, we can prove this one just by using the definition of Laplace transform. If you take f of t equal to 1, f of t equal to 1, and we can write by definition of Laplace transform, it is L of f of t. Definition of Laplace transform, L of f of t equal to integration 0 to infinity e raised to minus st f of t dt. This is the definition of Laplace transform. You have taken f of t as 1, that is L of 1. L of 1 is equal to integration 0 to infinity e raised to minus st f of t is 1 dt. Now, it is integration 0 to infinity e raised to minus st dt. Now, integrate with respect to t. Now, it is e raised to minus st by minus s from 0 to infinity. E raised to ax integration, you must familiar with the integration formula, integration of e raised to ax by a. Now, substitute upper limit minus lower limit, simplify. Now, this is e raised to minus infinity by minus s minus e raised to 0 by minus s, upper limit minus lower limit. Now, e raised to minus infinity is 0, the first term is 0, second term e raised to 0 is 1, minus into minus it is plus 1. Now, this equal to, it is 1 by s. Therefore, L of 1 equal to 1 by s. This is very simple, just all the basic formulas, just by using the definition of Laplace transform, we can find the required formula. Now, if you take the second one, second one is L of e raised to at equal to 1 divided by s minus a, e raised to 1 divided by s minus a. Yes. Now, here you have to consider f of t as e raised to at. By using the definition of Laplace transform, L of f of t equal to integration 0 to infinity e raised to minus st f of t dt. Now, your f of t is e raised to at. L of e raised to at equal to integration 0 to infinity e raised to minus st. Substitute the value of f of t, e raised to at into dt, that is equal to integration 0 to infinity. Simplify, bases are same, add the power and take minus sign outside, s minus a into t dt, e raised to minus s minus a, e raised to minus st, minus into minus plus e raised to at, bases are same, add the power. Then once again use this integration formula, integration e raised to ax dx, e raised to ax by a, it is e raised to minus s minus a into t divided by minus s minus a from 0 to infinity, e raised to ax dx, e raised to ax by a. Now, once again simplify, just substituting upper limit minus lower limit, in place of t you have to substitute the first term e raised to minus infinity by minus s minus a, upper limit minus lower limit e raised to 0 divided by minus s minus a. In place of t you have to substitute upper limit minus lower limit. Once again this is e raised to minus infinity is 0, therefore first term is 0, second term minus into minus it is plus and e raised to 0 is 1. Therefore, you are getting it is 1 divided by s minus a. Therefore, L of e raised to at equal to, it is 1 divided by s minus a. Yes, similar to the first derivation only, we did the second one. Next, third one, what is third one? L of t raised to n equal to n factorial divided by s raised to n plus 1. Now, we will do the third one, third formula, third one, L of t raised to n equal to n factorial divided by s raised to n plus 1. Proof, let f of t equal to t raised to n. Your function is f of t is t raised to n. Now, by using the definition of Laplace transform, what is L of f of t equal to integration 0 to infinity e raised to minus st f of t. This is your definition of Laplace transform. Now put the value of f of t, that is L of t raised to n equal to integration 0 to infinity e raised to minus st t raised to n into dt. F of t is t raised to n. Now how to do this integration? Now here it is a product of two function and one of the function is exponential. Now here you have to use the substitution. Substitution is whatever the exponential function e st equal to p. It is, you have to do the integration with respect to t. It is the product of two function. Here you should not use the product of two function, integration by parts. Here one of the function is exponential, then you have to use this substitution. What is that substitution? Whatever the exponential function is there, st equal to p. Then what happens? S is parameter, s into dt equal to dp. Now you can write integration 0 to infinity e raised to minus p. Then what is t value? T, st is p, t is p by s, s whole to the power of n. Then what is dt? It is dp by s only. S dt is dp, dt is dp by s. Now integration is with respect to p. Now it is p raised to n by s raised to n and s. With respect to p, s is constant. You can take outside the integral sign. It become s raised to n plus 1. P raised to n by s raised to n into s. S raised to n into s is s raised to n plus 1 in the denominator. Now integration 0 to infinity. What is your remaining function? E raised to minus p, p raised to n dp. Now again you are getting in terms of product of two function. Again here it is not possible. Again it is a product of two function. One of the function is exponential. Then how to do this integration? Now already studied, it is one of the integration in the integral calculus. You have studied beta and gamma function. Now in the gamma function, gamma n equal to integration 0 to infinity e raised to minus x, x raised to n minus 1 dx. This is the definition of the gamma function. You are studied in integral calculus, gamma n equal to integration 0 to infinity e raised to minus x, x raised to n minus 1 dx. By using this formula, it is 1 divided by s raised to n plus 1, it is gamma n plus 1. And we know gamma n plus 1 is n factorial. Therefore, this is 1 divided by s raised to n plus 1, it is n factorial, n factorial. Therefore, we can write L of t raised to n equal to n factorial divided by s raised to n plus 1. This is for the t raised to n, function is t raised to n. Now here what we did, we use the definition of Laplace transform. then it is a product of two function, thereby you are using the substitution method. Then again we use the definition of gamma function and one more property gamma function, gamma n plus 1 equal to n factorial. Then we got the formula L of t raised to n equal to n factorial divided by s raised to n plus 1. Now this is the third formula. Next, fourth and fifth one. What is fourth and fifth one? It is the trigonometry function L of sin 80 and another one L of cos 80. Now we will do the first for sin 80, L of sin 80. Yes. Now we will do the fourth one. Fourth one, L of sin 80 equal to a divided by s square plus a square. Fourth, L of sin 80, a divided by s square plus a square. Now here the function is trigonometry function sin 80, your f of t is sin 80. Now by using the definition of Laplace transform, if you substitute the value of f of t is sin 80, integration 0 to infinity e raised to minus st. Now f of t is sin 80 dt. Now here you have substituted the value of f of t sin 80. Now integration is with respect to t. Now again it is the product of two function. How to do this integration? And it is the product of two function, then you have to use integration by parts. By using integration by parts, we have the standard formula. What is that? What is the standard formula? What is integration e raised to ax sin bx dx? What is the formula? Standard formula. Already you have studied in your lower class and also in the first semester. What is this is e raised to ax divided by a square plus b square. You have to remember the formula a sin bx minus b cos bx. This is one of the standard formula. Now by using this formula, you can write it as e raised to minus st divided by, what is your a here? You can write what is your a is minus s, and what is b? B is a only. Now e raised to minus ax, a is minus s, then minus s whole square plus a square into a is minus s sin 80, b is a minus what is b? A cos a t from 0 to infinity. You have written this integration by using one of the standard formula. Now you can substitute upper limit minus lower limit. Now simplify. Now what is your upper limit? Infinity. What is the value? E raised to minus infinity. By what is e raised to minus infinity? E raised to minus infinity is 0. 0 into anything is 0 only. That means the first term by putting the upper limit is you are getting 0. E raised to minus infinity is 0, 0 into anything is 0 minus. Next you put the lower limit. What is lower limit? 0. In place of t only you have to substitute. It is e raised to 0 divided by s square plus a square minus s sin 0 minus a cos 0. Now what is simplify? Now sin 0 is 0, cos 0 is 1, e raised to 0 is also 1, e raised to 0 is 1, sin 0 is 0 only, totally it is 0, cos 0 is 1, it is minus a in the bracket. Here outside it is minus, minus into minus it is plus, it is a divided by s square plus a square. This is fourth formula, L of sin 80 equal to, therefore L of sin 80 equal to a divided by s square plus a square. This is the fourth formula, and you have to remember all these 7 basic formulas, then only you can do the example or you can do the problems. These are the very fundamental formulas. This is L of sin 80. Similarly, we can do the fifth one. What is fifth one? Fifth one, L of cos 80 equal to s divided by s square plus a square. Now in place of sin, here you have to write it as cos. Now if you write in place of cos, in place of sin, if you write it as cos 80, now what is this? Again, how to do this integration? How to do this integration? Now I told here we have the product of two function, you have to do with respect to t. Now here we have to use again one of the standard formula by using integration by parts. Integration e raised to ax into cos bx dx. What is the formula? Both the formula you must remember, integration e raised to ax sin bx dx. For the fourth formula we did, but here it is cos bx dx. Now formula is e raised to ax a square plus b square a cos bx plus b sin bx. You have to remember all basic formulas of integration also, integration as well as all trigonometric formulas. Now once again here a is minus s and b is a only. Now if you substitute a as minus s, b as a, then it becomes e raised to minus st minus s whole square plus a square minus s cos 80 plus a sin 80. Then from 0 to infinity. Now put the upper limit minus lower limit and simplify. What happens if you put the upper limit infinity? Again here e raised to minus infinity. E raised to minus infinity is 0. 0 into anything is 0. Therefore, by putting upper limit you are getting as 0 minus what is lower limit, your a. Now substitute t equal to 0, then e raised to 0 divided by s square plus a square minus s cos 0 plus a sin 0. Now simplify here. Now sin 0 is 0, cos 0 is 1, e raised to 0 is also 1. Then minus into minus it is plus, you are left with numerator only s. It is s divided by s square plus a square. Therefore, your cos 80, Laplace transform of cos 80, it is s divided by s square plus a square. This is the fifth one. We did the L of sin 80 and L of cos 80. Then next one, you have to all basic formula, you must know how to get the result. All these formulas just using the definition of Laplace transform only. Now the sixth one, for hyperbolic function sin h 80, it is a divided by s square minus a square. It is a divided by s square minus a square. Now the function is here sin h 80 or f of t. Again, by using the definition, L of f of t equal to integration 0 to infinity e raised to minus st f of t dt. Substitute the value of f of t, L of sin h 80, Laplace transform of sin h 80 equal to integration 0 to infinity e raised to minus st sin h 80 dt. Now once again, here how to find the integration with respect to t. Here also it is product of two function. Here it is a hyperbolic function, another function is exponential. We can write this hyperbolic function in terms of exponential. How you are writing? By using the definition of hyperbolic function. We know sin h ax, e raised to ax minus e raised to minus ax by 2. Yes, convert this sin h 80 in terms of hyperbolic function, then it is easy to find the integration with respect to t. Now what happens? Integration 0 to infinity e raised to minus st e raised to ax 80 minus e raised to minus 80 divided by 2 into dt. This is by definition of hyperbolic function. Now easily we can integrate with respect to t. Denominator 2 is constant, you can take 2 outside, 1 by 2. Now you can split into 2 terms and integration is with respect to t and bases are same. What is e raised to minus st into e raised to 80? First term, integration 0 to infinity e raised to minus s minus a into t dt. This is your first term. E raised to minus st minus into minus plus e raised to 80 into dt. This is first term. Second term minus integration 0 to infinity. Now here e raised to minus s plus a into t dt. Minus sign you can take it outside because upper limit is infinity, you have to take minus sign outside. Now as usual it is integration of e raised to ax dx, e raised to ax by a. Now here just simple integration, first term e raised to minus s minus a t by minus s minus a from 0 to infinity. Now similarly minus again integration e raised to ax, e raised to minus s plus a t by s plus a from again from 0 to infinity. Now carefully simplify. Now upper limit minus lower limit. In both the cases upper limit is infinity, e raised to minus infinity is 0. Only you are left with the lower limit minus. Now if you simplify it is 1 by 2 upper limit e raised to minus infinity by minus s minus a minus lower limit e raised to 0 divided by minus s minus a. First term upper limit minus lower limit minus second term e raised to minus infinity by s plus a minus e raised to 0 divided by s plus a by putting upper limit minus lower limit. Now carefully simplify, this is again e raised to minus infinity is 0 only, e raised to minus infinity 0, and here in the second term also first term is e raised to minus infinity, it is also 0. Then what is by putting lower limit e raised to 0, here it's also 1, here is also 1. Now if you simplify what you will get, now this equal to 1 by 2, what is first term, it is minus into minus plus e raised to 0 is 1, it is 1 divided by s minus a minus minus into minus it is plus, it is 1 divided by s plus a, 1 divided by s plus a. That is, then next one is only ordinary simplification, just take LCM and simplify, it is 1 by 2. Now denominator is s minus a, s plus a, this is s plus a here it is, what is it? Here it is minus e raised to minus ax by a minus minus it is plus, here it is also minus. Therefore here we have it is minus sign, 1 divided by s minus a minus 1 divided by s plus a minus s minus a. Yes, carefully simplify. Now what happens, 1 by 2, this is a plus b, a minus b, algebraic formula, it is s square minus a square. What about numerator, s plus a minus s, minus into minus it is plus s, plus s minus s will get cancels, 1 by 2, it is 2a by s square minus a square. Now 2 will get cancels, therefore you are getting a divided by s square minus a square. Therefore your Laplace transform of sin h a t it is a divided by s square minus a square. This is your sixth formula, and similarly seventh one is it is also hyperbolic function cos h at only, cos h at. Now we know sin h ax. What is sin h ax? Already I told sin h ax. What is e raised to ax minus e raised to minus ax by 2. Here we used e raised to sin h ax, but in the seventh one what you have to use? Cos h ax. What is your formula? E raised to ax, in place of minus it is plus only, plus e raised to minus ax by 2. This is the only change. You see here what is the changes in the seventh one. In place of cos sin, it is cos h at, cos h at. What are the changes? What you get? What you have to get? S divided by s square minus a square. Now you have taken the function as cos h at, cos h at. Now use the definition of Laplace transform. Substitute the value of f of t, cos h at. Now instead of sin h ax, you can use the cos h ax. Instead of here it is minus, here it will be plus. Therefore we can write here plus cos h at, it is e raised to at plus e raised to minus at by 2. Then once again you 1 by 2 is constant, you can take it outside and split into two terms, e raised to minus s minus a into t dt, first term. Second term, in place of minus, here it is plus only, here also it is plus, everything will be the same, there is no change. In place of minus, here it is plus, here also plus. Now once again use the integration, e raised to ax by a, then substitute upper limit minus lower limit, simplify. Here you made plus plus plus, here also minus into minus it is plus, you are getting here plus 1 by 2 into 1 divided by s minus a plus 1 divided by s plus a, here you are getting plus only. Then what you are getting here, s plus a plus s minus a, s plus a, s minus a. Now here constant a will get cancels, you are getting 2s divided by s square minus a, same simplification. Again take LCM and simplify, this is a minus b, a plus b, a square minus b square. Here once again 2 will get cancels, you are getting s divided by s square minus a square. Therefore what is the last formula, basic formula? Laplace transform of cos h at, Laplace transform of cos h at, it is s divided by s square plus a square. These are the very basic formulas in the Laplace transform. Then next after this you have to study about the properties of Laplace transform. There are many properties. There are many properties. First one is very fundamental property. Yes. Now, the first property of Laplace transform is very fundamental, as we do in the differential calculus or in the integral calculus. What is linearity property? First property is linearity property. In the linearity property, we take the constant outside the operator. As in differentiation, we take the constant outside the derivative, and also in integration, we are taking the constant outside the integral sign. Here also, in the Laplace transform, we take the constant outside the Laplace transform operator. What is that? If L of f of t equal to f of s, which we will write very briefly as f of s, and L of g of t equal to g of s, then L of if I take C1 f1 t f of t plus C2 another function g of t, Laplace transform of C1 f of t plus C2 g of t is equal to how we will write C1 is constant L of f of t plus C2 is L of g of t. What here C1 and C2 are constant only. Yes, here C1 f of t plus C2 g of t, this is your function. Here L is the Laplace transform operator, you have taken constant outside the Laplace transform operator, and these properties we can do just by using the definition of Laplace transform only. Proof is very simple, but just by using the definition of Laplace transform. And similarly, we have the other properties, first shifting properties, multiplication by t raised to n property, division by t, periodic function, and second shifting property. We will discuss in the next session, and today we did only the definition of Laplace transform and also very basic formulas, standard formulas of Laplace transform. If you know these basic formulas, then easily we can do the problems. You have to memorize all these basic formulas. Thank you.